Welcome back to Beyond Fuel. In today's video, we're diving into the fascinating world of hydrogen. Get ready to explore the many colors of hydrogen and uncover why this element is crucial for our future. Hydrogen, the simplest and most abundant element in the universe, holds immense potential as a clean energy source. But did you know that hydrogen comes in different colors? That's right. In this video, we'll be exploring the three main types of hydrogen: gray, blue, and green. So, if you're ready to unlock the secrets behind these captivating colors and learn how they can shape our energy landscape, you've come to the right place. So let's get started. Hydrogen is the simplest and most abundant element in the universe. It's a colorless, odorless, and tasteless gas that has a wide range of applications. Hydrogen is used in fuel cells to generate electricity, in the production of ammonia for fertilizers, and in the refining of crude oil. Hydrogen is also a promising clean energy source that can help reduce greenhouse gas emissions. When hydrogen is used in fuel cells, it produces electricity and water as byproducts, making it a zero-emission energy source. Hydrogen comes in different colors, which refer to how it's produced. The three main types of hydrogen are gray, blue, and green hydrogen. Gray hydrogen is the most common type of hydrogen produced globally and serves as the foundation of the hydrogen industry. Its production process primarily involves a method known as steam methane reforming, SMR. During SMR, natural gas, methane, is reacted with high-temperature steam, resulting in the production of hydrogen and carbon dioxide. Gray hydrogen production comes with certain advantages, notably an established and extensive infrastructure that facilitates its production and distribution, rendering it easily accessible. Moreover, it has a reputation for cost efficiency, historically being the most economically viable method for hydrogen production. However, this method is not without its drawbacks, chief among them being its significant carbon emissions. The production process releases carbon dioxide into the atmosphere, thereby contributing to greenhouse gas emissions and exacerbating the issue of climate change. Consequently, gray hydrogen is regarded as an environmentally unsustainable energy source within the context of climate change mitigation. Blue hydrogen is seen as a transitional step toward cleaner hydrogen production. It employs the same steam methane reforming process as gray hydrogen, but with an added step to mitigate carbon emissions. Blue hydrogen offers distinct advantages, primarily characterized by its integration of carbon capture and storage, CCS technology. This innovative approach captures the carbon dioxide emissions produced during steam methane reforming and safely stores them underground, preventing their release into the atmosphere. Consequently, blue hydrogen achieves a substantial reduction in carbon emissions compared to gray hydrogen, positioning it as a more environmentally friendly choice. However, blue hydrogen does come with its limitations, notably the added complexity and cost associated with the implementation of carbon capture and storage technology, rendering it a relatively more expensive option than gray hydrogen. Additionally, the effectiveness of blue hydrogen hinges on the successful deployment of CCS technology, which may encounter technical and regulatory challenges, potentially affecting its viability. Green hydrogen is hailed as the cleanest form of hydrogen production, relying on renewable energy sources for its creation. Green hydrogen boasts several compelling advantages, including its remarkable attribute of producing zero carbon emissions. This feat is achieved by harnessing renewable energy sources like wind or solar power to conduct electrolysis, efficiently splitting water into hydrogen and oxygen. Consequently, green hydrogen aligns seamlessly with the critical goals of climate change mitigation and the reduction of greenhouse gas emissions, establishing itself as a sustainable energy source. Its versatility further enhances its appeal, finding applications across diverse sectors, from transportation to industrial settings. However, green hydrogen encounters significant challenges, with high production costs being a primary hurdle. This arises from the substantial initial investments required to develop renewable energy infrastructure. Additionally, the intermittency of renewable energy sources poses a practical concern, as consistent access to these sources is essential for reliable green hydrogen production. To fully realize its potential, substantial development of infrastructure, including electrolysis facilities and storage solutions, is imperative to support large-scale production and distribution effectively. Each type of hydrogen has its own unique production method, and understanding these methods is key to grasping the environmental implications associated with hydrogen production. This is the traditional workhorse of hydrogen production. Gray hydrogen is produced through a process known as steam methane reforming. Here's how it works. Natural gas, which primarily consists of methane, is mixed with high-temperature steam in a chemical reaction. This process results in the production of hydrogen and carbon dioxide as byproducts. Blue hydrogen, as mentioned earlier, is a cleaner alternative to gray hydrogen. It still relies on steam methane reforming to produce hydrogen, just like gray hydrogen. However, the distinguishing feature here is the inclusion of carbon capture and storage technology. CCS captures the carbon dioxide emissions produced during SMR and safely stores them underground, preventing them from entering the atmosphere and contributing to global warming. Now, green hydrogen takes a totally different route. It's produced through a process called electrolysis. Here's the scoop. Water, H2O, is the starting point, and it's split into its two basic elements, hydrogen, H2, and oxygen, O2. This separation is achieved by running an electric current through the water. But here's the green twist. This electric current is generated by renewable energy sources like wind or solar power. So, in essence, green hydrogen is created using renewable electricity, and it's as clean as hydrogen production can get. Now let's talk about the environmental impact of these production methods, which can vary significantly. Unfortunately, gray hydrogen doesn't have a great track record when it comes to the environment. The process releases substantial carbon emissions into the atmosphere due to the carbon dioxide produced during SMR. This makes gray hydrogen a contributor to climate change and a less desirable option for a sustainable future. Blue hydrogen, thanks to the incorporation of CCS technology, is a step in the right direction. It significantly reduces carbon emissions compared to gray hydrogen. By capturing and storing CO2 underground, blue hydrogen is a more environmentally friendly choice, though it's not entirely carbon neutral. This is where things get exciting from an environmental standpoint. Green hydrogen production has zero carbon emissions. Since it relies on renewable energy sources like wind and solar power, the process doesn't release any harmful greenhouse gases into the atmosphere. It's essentially the holy grail of clean hydrogen production. However, there's a catch with green hydrogen, and it's the need for substantial upfront investment in renewable energy infrastructure to generate the required electricity for electrolysis. So, while it's incredibly eco-friendly, it's currently more challenging to scale up due to the cost associated with building and expanding renewable energy systems. In conclusion, we've explored the many colors of hydrogen and how they're produced. We discussed the environmental impact and carbon emissions associated with each method and highlighted the benefits of green hydrogen as a clean energy source. While there are several challenges associated with widespread adoption of green hydrogen, it holds immense potential as a zero-emission energy source that can help mitigate climate change. Thank you for watching. Don't forget to like this video if you found it informative and subscribe to our channel for more content on clean energy solutions.